So, I shows yous a 2 kilogram object at 10 meters a second, 30 degrees north of west. And when I write that, I'm thinking about some questions on this sheet from yesterday and wondering why nobody's asking my y. On some I do x and y, on other ones I just use momentum.
Why is that, Walter?
Oh, a good question. If you just got a question like this, that car is like that and that car is like that, you may as well just, they're 90-degree angles to one another. So you may as well just use components and use Pythagoras. It'll work. Now, it'll also work if you break each one. Momentum before in the x direction is momentum after in the x direction, and do each one. But because it's all x and all y, there isn't this stuff going on. It might be easier to just look at momentum here, here, and then solve it for that. Okay? But if you don't want more than one way to do a question, then forget I said this and just do everything with x's and y's. So that's why when you look at the solutions, some of them are done that way. And then for this, you would have to do x and y, okay? Oh, actually, I shouldn't say that because there are other ways. I'll show you that in a sec. So anyway, this thing is not going exactly in an x or a y direction. So is hit by a bludgeon and then travels at 12 meters a second north. Means due north. What impulse? Now, what is impulse? Change in momentum. Delta P. So if something's going some way, and then that momentum is changed, well, I can define that as a change in the momentum. And I'm going to have a new direction for momentum. And remember, momentum is a vector quantity. That's why we write it with arrows, just like a force. What impulse is given? I could say to the object, or the other way is by the bludgeon. So, hey, what's your response? Do we need to know? What's a bludgeon? There. Bludgeon. No.
Oh, from those games that had wings?
It's a sphere. Do we need to know what a bludgeon is to do the question?
Yeah, I like to imagine.
How about you cross off bludgeon and write heavy mosquito? Ooh. So, initially, this is what's going on, right? Where's that? 30 degrees north of due west. So, make it look reasonably accurate. But is this right? Like, this is my velocity, but what do I want to do here? Like, velocity is a vector, but velocity is not conserved. Momentum is. So let's just make that momentum right off the bat, okay? Mass times velocity at that angle. What's going on? It gets hit by this thing. Do I know the direction of this thing? Well, hang on, don't say obvious. I don't know the direction of that thing, but I may be able to figure it out if I keep reading, because what's the word then mean? After, or what's after in physics? In kinematics, we called that final. I do have a final. Finally, it travels at 12, okay, times 2, due north. So, what's going on? Do we know if that's the way you're going and that's the way you ended up? And this is kind of hard for some people. Can you visualize what must have happened to this thing? And if I wrote choices, which one do you like? Because it's not entirely clear. You like C, B, or A? It kind of hurts my head. It does. Because remember, these aren't really drawn to scale here, right? Remember, if this thing is, I mean, how much effect is it going to have on this? Negligible, right? But it's not. So, but we can, I mean, obviously it's not like this, right? We're pretty clear it's not this, right? So, well, if I'm not gonna add these head to tail, because that's not what the second thing is. But something happened, and then that's my resultant. So do you know how to add these? It is possible. That's what's going to happen, right? Now that's a little bit longer than that guy. So by this account, that is kind of the direction it's going. Okay? Is that what we guessed? I can't remember. Yeah, whatever letter it was. Okay? So you can just go to there, but I'm going to show you a better way to do it. So that's initial. That's final. What do I call this? That's what changed. And what's another word for that? Yeah, that's what the question is. What impulse? That means this, right? That's what I'm trying to get. So if you think you can do that, and on this question, I'll just say it's a lot easier than one of the ones in your assignment, feel free. But what's a better way? What is a formula for change in momentum? Final minus initial, just like velocity, right? So what I'm going to do is go final, that's this thing, and I'm going to minus my initial. Right? Which means delta P then, that's final. The negative vector of this is this exactly the same magnitude in exactly the other direction, right? So then I can add them. Remember this stuff? Okay, I don't want to subtract these. I'd rather add, because I know how to add vectors. I add them tip to tail. So when I do that, let's move that over a bit. Then I get that, which is 12 times 2. Add this head to tail, which is, that's a little shorter. So if I draw it reasonably accurate, do I kind of get the same direction? Well, yeah, right? So again, I don't care which way you do it, but I think this way takes a lot less brain power. It's less likely you're going to make a mistake. Just the formula? Vx, Vy kind of thing? Yeah? Yeah, because this has two components, right? But you remember, you don't want to subtract this, you want to add it. Because I want to get that. I'm not solving for one of these. This is how I recommend you do it. Okay, that's all I'm going to say. You want to figure out your other way to try to do it, be my guest. Okay, so how do I solve for that? That is the impulse. That's the change in momentum. What are these angles? That's 30 degrees. So we are going to do that. Px before is px after, and then I'll show you another way. So before, what I got? 20 cos 30. Okay, that's 20. I want x here, so that's the cosine. Okay, is px. That is 17.32. What's py? Negative 20 sine 30 for this guy. Okay, why is it negative? That's the same angle, right? So that is 20 cosine 30. This is 20 sine 30. Yeah, because it's going in the negative direction. I'm taking up as positive, so I'm going to do that. Okay, but what else do I have here for y? That's all I had for x, because this guy was directly north. I also got this. That's 24, no direction, right? Because it is straight up, positive for y. That's, well, it's py right over here. Okay, which is, apparently that's 14. I guess 0.0. So change in change in p. If I got that, that's positive. That means it's going that way. That's positive. So it's going that way. Little shorter. That's the change in it. Okay, and we know how to do that. That squared and that squared, take the square root. And I got that, but it's a vector. I need to know direction. So inverse tangent, excuse me. Now I'm kind of whipping through this a bit because I'm going to show you the other way, which is what? 39 degrees north of due east. Okay? Or, okay, I can't tell you to do it this way. But let's redraw this guy. That was 12 times 2. And if, again, everyone saw that, right? If that's 30, this is 30. This is 20, 10 times 2. And I want to find that. So using cosine law, cosine of That's the angle I need. Which angle is that? Using cosine law, I need to know side, angle, side, right? It's always the angle in between the two sides. So that has to be in between these two. I got to have that right there. But that's pretty easy to figure out. What angle is that? Why is that, Colton? Because that's due east, this is due north, that's 90 degrees, right? Yeah, so that's got to be 60. So delta P is 24 squared and 20 squared minus 2 times 24 times 20 cosine 60. Yeah. Haven't you already? As I said, you could before. Oh, I wasn't doing it then. I might now. So, with any luck, I get the same thing. It's cosine of 60 in radians, Jake. Oh, you guys taken math 11 too, haven't you? Oh, Meryl's taken math 12. What's cosine 60?
1/8.
It's the same as sine 30, which is 1/2. I know, a memory like a sieve, right? Hey, I got the same thing. 22.3. Now, still need an angle, don't I? All right, so sine law says the sine of 60 over 22.3 is the sine of, what angle do I want? Well, I actually kind of want that one, but first I'll get that one, and then I know that's also a right angle. So that is the sine of, let's call it theta, over 20. So 20 sine 60 divided by 22.3 is the inverse sine of that angle. So inverse sine of that is 51 degrees. That's not right. That's 51 degrees east of north. Is that the same thing as 39 north of east? It is. So, got the same answer. Okay, that is 39 degrees. That is 51 degrees. Nothing. It's exactly the same angle. It's exactly the same direction. Right? Look. This is 20 degrees westward of north, but it's also 70 degrees north of due west. Same thing. Oh. All right, so you can do all except 1 and 9. Those are explosions. I'll show you another example tomorrow for those puppies.